everyone, I'm Rotaract Joint PD Director of NanoCCS. Talking about the Chem Talk project. This is initiated by the Rotaract of College of Chemical Sciences. So this is actually a YouTube series that will be uploading all the videos to our YouTube channel, NanoCCS. So don't forget to subscribe it. So guys, without further ado, let's move on to our show. Welcome you, sir. It is our privilege to have you here today. So, Dr. Gayan Priyadarshana, he's a nanotechnologist and a polymer scientist, received his Bachelor of Science Special Degree in Chemistry from the University of Sri Jayawardenepura. Then, he went to acquire his Master of Science degree in Chemical and Process Engineering at the University of Moradua. For his PhD in Chemical Sciences at the University of Peradeniya. So during and after the PhD, he was worked as a research scientist and senior research scientist at the Sri Lanka Institute of Nanotechnology for about 10 years. In 2019, he joined the Department of Materials and Mechanical Technology in the Faculty of Technology at the University of Sri Jayawardenepura, where he is currently working as senior lecturer. Alright guys, so before we get into our topic today, we would love to hear your thoughts on how to excel as an undergraduate.
Good morning, Nandya. Actually, first of all, I would like to express my sincere thanks to you for selecting me as the resource person in your very first program. So if I answer your question actually, so you know, during this period we are facing a huge economic crisis. Actually, you can say rather socio-economic crisis after that pandemic situation, and also as a result of that we faced inflation in our country. So as a result of everything, so we are in a very crucial situation. So therefore we can't say that individual contributions. Now we have to think as a nation. So therefore not only as undergraduates or graduates or the scholars, but also as a country members. So we have an equal responsibility to address these issues and come with some solutions in order to achieve these targets, right? So therefore, that's why I mentioned that it is not a thing limited to undergraduate or graduate student. But anyway, as you mentioned, so you as undergraduates are very important in this case, because maybe you know, I have seen from some resources actually the students who are qualified for O-level, I mean after A-levels, the students who are qualified from A-levels, 17% of the students only getting the opportunity to join this type of higher education sector. If you take a whole students who are facing the advanced level examination, only 2% are getting the opportunity to become persons like you actually. So that's why I mentioned undergraduates are very important in that case. So therefore you as students has a major role to play in that case. So therefore you have to actually save yourself to face that particular cases. So this is therefore we can't say that we as students, you also, even myself, I was in working as in your university life while doing the studies as students, not only limited to you, for all actually you are facing more trouble some life you are having. So therefore with that everything, in order to get focused on your studies is the most important thing. So in that case, by getting some examples from myself as well, because I was also a student sometime. So therefore, I would like to give some advices to the undergraduate students who are starting their career, like students in your institutes and whatever the state universities or private universities. So first of all, you should have a goal. Actually, you should set goals always, because the goals you can have short-term goals or long-term goals. And you can set some milestones in your life, because your ultimate, as a student, your ultimate target is to become a professional, right? So become academia, to join academia. So then, but that should be your long-term goal. But in order to achieve that, so you have to have short-term plans as well. So your very first thing to, I mean, face your examinations, and by that you can year to year you can have that milestones, right? Then you can do some self-evaluation by yourself. No need to have another one. So you can do some self-evaluation. How far you have achieved the milestones that you have set at the beginning. So if you have achieved so then you can oversee or forecast what are the things that I can achieve at the next level. So those are very important things. So therefore, setting goals are very important because it will provide you some directions to your targets, right? So therefore, that's why I said at the very first time, the goals are very important, and it will increase your attitudes, right? And also the focusing. Focusing is also very important because if you lose your focus, if you lost your focus, then you can't go for that target, right? So therefore, focusing is very important. That will give by the setting of the goals, and also it will improve your motivation factor and also the effort. So you can give a tremendous effort in order to achieve your targets, right? So therefore, and another thing that by setting the goals, you can improve your effectiveness, right? So that is one thing. And also the second thing that I have to mention, that you always have to have the positive attitudes, right? So can-do attitude, always, even in the examinations, even when you face to another person, so always you have to have a positive attitude. So if you have positive attitudes, then you can plan your everything in a correct direction. Otherwise, always you are feeling that no, I can't do that. I have to get it into another person, and I have to give it to another person. No, you can always think that I can do it. So that is the major thing, right? Positive attitudes. And also the next thing, so you have to manage your time. So when you attend your lectures, and when you do your studies, and when you prepare yourself for your examinations, and for everything, that you have to manage your time. So you have to have realistic time schedules. It has to be realistic. If you set some unrealistic schedules, it won't work, right? So therefore, you have to make sure that whenever you make the schedules, it should be realistic. So therefore, that is one thing. And the another thing is that as students, basically undergraduates, you have to refer most textbooks. That's the most important thing, because you can listen to the lecture and all, it is okay, but to get the definitions, to get more knowledge, to become a more knowledgeable person, you have to have that attitude that you have to refer textbooks. Always studying textbooks is very important, and you can get some important things and you can highlight them, and you can, sometimes you might not need to go to each and every textbooks and each and every page, but you can select some specific pages, specific sections or chapters, whatever you think that it will be helpful for your future things, right? That is one thing. And also one thing that I can see in this time period, students are not participating in the lectures. No. So during the pandemic situation, we experienced many online lectures, right? But sometimes in some of the lectures, fortunately in my lectures there are some students are there, but some lecturers are, even sometimes for myself, to be honest, majority is not there. So if you have 20 students, only 5 to 10 students are there. So it's a demotivation for the lecturer, and also it will react to the back to the students as well. So therefore, attending lectures is very important, because always whatever the thing that lecturer mentioned at the lecture, you can argue it. It should be very friendly, and it should be a positive argument. So you can ask questions whenever you have, so you can get back the answers as well at that moment. So, and also during the lectures you can keep notes, and you can keep some updates, and you can mention something that you need to ask from the lecturer next lecture also. So therefore the participation lecture is very important. And another thing which come to my mind is actually you have to study well, because once you get all the things in your files, but the students do is actually, normally they keep them in one place, and once they come to the examinations only, they try to refer to those lecture notes, right? But it is very, it's not a good habit, because sometimes you might heard that there's a forgetting curve, right? So the thing like forgetting curve. So they have analyzed that once you get, listen to the lecture. Let's say you have listened to a 1 hour lecture. So after 1 hour, 80% of whatever you learn will be lost from your mind. So only 20% will be remain. So now you can imagine if after 1 hour, if it is reduced up to 20%. So when you face to the examination after 6 months, sometimes 0% will be remain in your mind, right? So therefore, you have to break that forgetting curve. There are some methods you can read and you can get from YouTube as well. There are methods you can overcome that thing. So this is not trying to tell all about those things. So therefore, you have to study well and you have to have a plan. So that's where the plan comes again, right? So therefore, you plan it and you face the exam. And another thing that most of the students, what they are doing actually, when they come to the closer to the exam, so they do overnight reading and they don't sleep actually. But believe me that 8-hour sleep is very important. So otherwise you will lose everything, because you have to have a healthful person before you sit the exam. And final thing is that you have to sit the exam. Nowadays, again, it's a trending thing that all the students are trying to give the medicals, right? So they give medicals and saying that we will postpone it to the next semester or next year. Yes, so that they use as a, so it's a very bad habit that nowadays students are practicing. So those are the things. And on top of that, you have to be an honest person. You have to be a very peaceful person, and you have to respect to others. And finally, you have to serve the country. So always, my advice is, if you born in this country, you learn from this country, you have to work for this country. So that is what I feel that undergraduate, he has to be put it in mind, and he has to practice.
Thank you very much, sir, for that valuable answer. So guys, as undergraduates, we all have these sort of questions. I hope from his explanation, most of them have been answered. So, moving on to our next question. Before that, I'll start with a small description. Many scientists consider nanotechnology as the next logical step in science, integrating engineering with biology, chemistry, medicine, and physics. In the last couple of years, the term nanotechnology has become almost synonymous for things that are innovative and highly promising. So, nanotechnology has been gaining a lot of attention in the recent past. So, how new is this field?
So, actually, I can give you two answers for that question. Yes, it is a new field, and I can, at the same time, I can say no, not a new field, because the reason, actually, as scientists, normally what we do is actually we do experiments, and by doing the experiments, you can see some observations. Based on that observation, you come to sort of conclusions, right? So if you can see something, only that you can give some explanation about that. But if you can't see these nanoparticles, if you can't see this nano world, how can you explain about this? So that was the question. Actually, the reason why I'm telling like that, very ancient time, like 4th or 3rd century, this technology has been utilized by people, even without knowing that they are using this technology, right? So maybe you have seen some ancient churches. There are some stained glasses are there, blue color, red color, green color, so on. There are many color glasses. So nowadays people have realized or invented that they have used gold nanoparticles, silver nanoparticles in their nano form in order to get that different colors. And another good example for that is actually in 300 BC time, so very ancient time, right? So people have used swords. We call this Damascus sword. Maybe you will have heard that. So in that, in order to make that Damascus sword, they have used carbon nanotubes and some ceramic nanowires incorporated to form that very sharp swords, right? So those are two examples. There are many more examples. People have been utilized this technology without knowing that. But by the time passed, Actually, in 1931, actually, there was a tremendous invention that they have found transmission electron microscope. We call it as TEM, and now later it's scanning electron microscope, atomic force microscope, which are the equipment you can use to zoom these materials and you can magnify it. And if you, for example, if you take a transmission electron microscope, you can see up to the atomic structure. So you can see the atoms, right? In scanning electron microscope, you can go up to nano level. So you can see nanoparticles. But you can't achieve that from general optical microscopes, because you know the resolution is the factor and the magnification, right? So if you can't resolve two particles apart, so you can't see it as particles, then you will see it as color material. But by that, only by looking at that, you can't give the conclusions, right? So that was the problem, actually. So therefore, after the evolvement of those magnetic microscopic techniques, then people have started doing some research on that. Then in 1959, actually, Sir Richard Feynman is the first person who mentioned that plenty of room at the bottom. So that particular wording says that when you go up to the lower levels, in nano level, there are many more applications because of their huge, exceptional properties. So he got the Nobel Prize in 1965 for that particular case. He's a physicist. So then only the world, the scientists are looking into that particular technology. That's why I say yes, because 1959 to today, only 62 years, right? So therefore it's about 60 years old technology. So my age is 42, right? You can realize. So how new that technology, but very importantly, even though this is a very newly emerged technology, you know, now out of the publications, out of the science cited publications, 7% of the publications are related to nanotechnology. Out of everything. So there are huge fields, biological, medicine field, and many fields, right, agriculture field, but nanotechnology is only, by nanotechnology, getting 7% out of the entire publications during 2016 to 21 they have done a survey. So therefore, that's why I mentioned, this is we can categorize this as a new field, and also this was a very ancient technique, but people have not seen that, not observed that. So only recently they could be able to realize that there is a special beauty in that particular scale. I will explain you about the nanotechnology and how this size is more important in that case. I think for your question, yes, it's a new technology, but people are very they are very enthusiastic about how to do these techniques and how to come across the short paths to overcome the existing problems using nanotechnology. Because as the Feynman said, you can achieve more with less. So if you talk about nanotechnology, you can achieve more properties, more elevated properties with very less amount of the material. So it's the answer to your question is it's a new technology, 60 years old technology.
Alright, I think we have come to the best part of the topic, nanotechnology. So this is a very novel field. Can you tell us more about this nanoscience and nanotechnology? Like, can you give us an exact definition for this?
Yes, Nadia, actually it's very difficult for me to explain everything with that short time because it's a broad subject. However, if I come to and if I get an approach to explain you about this technology, before that I will ask you a few questions if you are giving me permission. So you know size of the, if you take the length, 1 meter you are familiar, no?
Yes.
And centimeter, millimeter, and then what? Micrometer,
and
nanometers, and angstrom. So if you take the scale. So do you know how small this nanometer scale when you compare to the meter scale? So actually, okay, I will give you the answer.
Yeah, that's really hard.
So it's a 1 billionth of a meter, right? 1 nanometer is equal 1 billionth of a meter, 10 to the power minus 9. right? If I give you a very small example, you think one diameter of 1 meter as of the earth, right? And you take football is the diameter of 1 nanometer. Now you compare the size difference. So earth to football. So that much of very small particle we are talking about, right? So then why this nano scale is very important. And also the people are having questions. Now nanometer scale means from 1 nano to 1000 up to 1000 nanometer. 1000 nanometer is equal to 1 micron. So 1 nanometer to 1000 nanometer is nanoscale. However, in this nanotechnology, we are not utilizing that whole entire scale. So we are focusing only 1 to 100 nanometer scale. There should be a reason for that, right? So I will explain that. So when the particle size reduces, right? So their active surface area will impact. So now actually, I will take an example. If you take, let's say, a cube, 1 meter size cube. So it has a specific volume, right? Now, if you cut it into 2 pieces, right? So it will, its volume will remain unchanged, but the specific surface area will be increased, right? And if you slice it furthermore, right? If it reduce the size furthermore, again, then what will happen? Your surface area will be increased, but the volume will remain unchanged. So if you draw a graph against the specific surface area and the particle size of the material, let's say the cube, so it will very slowly increase the specific surface area, or the surface area to volume ratio will be slowly increase. But after that 100 nanometer scale, 100 to 1 range, you can see a dramatic increment of that particular specific surface area. So that is the reason why people are going for that particular range, because otherwise they will not get that particular property increment as they expected. Property, I mean, I tell about properties, whatever the properties. It can be optical properties, it can be magnetic properties, it can be mechanical or physical properties, chemical, whatever the properties, all are getting tremendously enhanced, because all of those things will be, depending upon the interactions between these 2 surfaces, right? So once you increase the surface area, those interactions will be rapidly increased, and also due to that, the van der Waals forces and other forces will be coming into action, and they will give those property enhancement into the material. So that's why the particle size is very important. And as I mentioned, the optical properties, I will give you one example. If I ask you the question, what is the color of gold? So you are wearing jewelries, right? So gold, the color is gold. But I will tell you, in nano world, when you come to nano scale, you can get any color using gold nanoparticles. You can get the rainbow colors, start from green to yellow to pink or blue, whatever the colors you can achieve. So that is why, as I mentioned, in that ancient time, people have utilized that into their stained glasses as well. So you can see from these some images, the gold are having different colors. So therefore, their optical properties are getting changed in that scale. And also the strength of the material. For example, now you know the graphite. Right? Graphite is very weak material. We have graphite mines in Sri Lanka, Bogada, and so on. Those are very weak materials. But if you synthesize carbon nanotube, you can synthesize carbon nanotube with from that same graphite. Carbon nanotube is the most strengthened material in the universe. It is more strengthened than the metals, right? So then now you can imagine how these properties are getting changed when you come from macro world to nano world, right? So that is the beauty of that. As I mentioned, so if you have equipment to see those particles, their shape and all, then you can do studies, right? Nowadays we have that luxury, that facility is there. So you can use scanning electron microscopes, you can use transmission electron microscopes, and there are some other equipments called atomic force microscope and electron tunneling microscopes. So those equipments and particle size analyzers are there. So by utilizing those equipments, you can have a good idea about what is the size of the material and what is the shape of the material, how it distributed among the particles range. So those things can be achieved. So get into your knowledge. So therefore, nowadays people are doing some research on that, right? So that is briefly the nanotechnology, how that scale and what is the reason for using that particular scale. That is the answer for that. Right. Another important thing in these nanomaterials, Nadia, actually, these are very small. I told you that these are very small, minute particles, right? So now, therefore, they are having very high surface area. Due to that factor, they are highly reactive. So you know that whenever they are reactive and they are more active and they are having high energy, so those are very unstable. So therefore, there is a natural tendency. Those particles always try to do some agglomeration, form some agglomeration. Agglomeration in the sense they try to get together to form bigger particles, right? So it is very hard for us to keep them in nanoscale because, as I mentioned, so those are having high energy. So always they try to agglomerate and sediment, right? So that is where the challenge is. Actually, the nanoscience technologists or the scientists, they are always keening about that part because you can synthesize nanomaterials. Basically, there are methods one method we call bottom-up approach, and there are some other techniques called top-down approach. Top-down approach means so you start with the bulk material. There are methods you use to get rid of the particle size. Very common method, milling and crushing and grinding, blending. So physical methods you use to step down the size. And other method is bottom-up approach. Bottom-up means you start with nothing. So basically, there are two chemicals, can be solutions, right? And then you mix them together. So then the reaction happens. As a result of that, the nucleation will form. Nucleation will nuclei will form and every places, and then the particle will be growth very rapidly. So while this particle growth, as I mentioned, so there is a tendency to get sedimentation. So then you have to use the technology in order to prevent that being agglomerated. So that is that we call as surface modification or surface functionalization. You can use some polymer materials, you can use some electrolytes, or you can use some iron, or you can chelate it into some sort of structures, or you can use some templates in order to synthesize. So there are methods we call in situ modification or ex situ modification. In situ means you are synthesizing the nanoparticle in the presence of the surface modifier. So when the particle is getting developed, so then that coating or the surface modifier will be covering that particular particle. Then that particle no longer capable of being attached to the next particle because that surface modified material will be hindered the met of the two particles. So then they will keep apart. So then they are showing some Brownian motion. Always the nanoparticles are not sedimenting. They are very highly active and they are showing brown. We call it as Brownian motion. That's why when you take a nano solution, we say nano dispersion basically, because there are these are not aqueous things. So these are particles. But when you take a sample, you can't see particles. Why is that? Because that particles are very small. You can't see two particles separate in your naked eye because we are using optical waves we see it, right? Because if your two particles are in between 1 lambda or half a lambda, in between half a lambda, you can't resolve that two particles. So that's why people have gone to the electromagnetic radiation. Those are having very narrow lambda, right? So then these particles can be separated. Then only we can see, right? So since these particles are very small, they are showing Brownian motion, so they are not settling down. So then we can see as a colored material, as a colored solution, but it's a dispersion, right? That's the way I mentioned. So when you make gold nanoparticles with their size and shape, so we call it as size, due to size and shape, both factors, they are showing some different colors, right? We can make rainbow colors. So we can see it as a solution, but it is a dispersion. We can't see the particles moving around because we are looking at our naked eye, by using our naked eye, right? So those are the things about that.
Thank you very much, sir, for that explanation. I think it has covered almost everything in this nanotechnology area. And now I'm curious about whether these nanomaterials are naturally occurring or not. So, Dr. Gayan, are nanomaterials naturally occurring?
Yes, Nadia, actually there are many examples I can tell you about to give the examples that the nanomaterials are naturally occurring. I will give you a few examples, right? So one good example is, I think you have seen lotus leaf.
Yes.
Lotus leaf, whenever the water droplets are, those are not attached to the lotus leaf, right? So, and also, have you ever thought how these geckos are climbing on the wall? And they are hanging on the ceilings, right?
Curious about that.
Right? So someone can say those are very small creatures, but their toes and foot are also very small.
Yeah.
So if it is the case, even we could be able to climb on these walls and hang on these ceilings, but we can't, right? So there should be reasons for that. And also, have you ever thought how these butterflies are getting different colors, and they are also having these hydrophobic or whatever effects in their wings? So those are actually the examples that the nanotechnology is in the natural system, right? So if I come to that particular lotus leaf thing first, so if you want, you can find it from the Google actually. So if you type lotus effect, so that entire phenomenon will be there. So in the lotus leaf actually, the people realize that only when they search it or they observe it through the electron microscopes, then only they saw the morphology of that particular leaf surface. So there are some epidermal microstructures are there on top of the lotus leaf. So it's a comb-like structure. We call it comb-like structure. So you imagine a comb, right? So in one comb, in one fibrous thing, so you have millions of crystalline wax nanofibers, right? So now you can imagine, now there is a microstructure, and on top of that there is a nanostructure, right? So therefore we call it as micro and nano structure, right? Combination. So as a result of that, whenever the debris are there, the dirt particles are there, when you have water droplet, so it will roll out because it will not be adhered to the surface of the lotus leaf because of that micro and nanostructure architecture, right? So therefore that the dirt particles will also get rid of during the flush of water. So that's why we call it as self-cleaning. People have studied more and more about this self-cleaning effect, and they have implemented it into the textiles. So therefore, I will come again. I will ask the next. I think you will be asked about the applications also you mentioned. So we will discuss that in detail. But however, in the textile industry, they have implemented that particular phenomenon into that fabrics. So they have created self-cleaning fabrics out of that. And there are some self-cleaning glasses are there. If you think about the building with 30 to 40 story buildings, so when they set those glasses in the wall, so how they clean that? So if you can just apply one coating of this nano coating, and then it will self-clean by itself, right? So once the rain comes, the dirt particles will be brushed off. So those are called self-cleaning effect, right? So the lotus leaf naturally having that facility, so it's not created by anyone, right? So it's a naturally occurring thing. So that's why I mentioned that it's a good example. And if we come to this gecko effect, so we call it as gecko effect. They are if you investigate the toe of the gecko or foot of the gecko, in 1 square millimeter, there are about 14,000 hair-like structures are there. 14,000 hair-like structure. In each of hair, there are at least 1,000 antenna kind of nano fibers are there. So therefore now again it is also similar to that particular lotus leaf. There are nano structures there. So now what will happen when you have nano fibrous structure? The surface area is increasing. So now when you compare the toe of this gecko, his one toe can hold his body weight, because whenever he touches the wall, that particular, not only his hand, toe, but all the fibers are getting touched with the wall. Then you can calculate the interactions, additional interaction due to the van der Waals forces. This toe of the gecko and wall will be interacted very highly due to that van der Waals forces, and as a result of that, the friction, due to friction, that particular one can adhere to the wall and it will not be fallen down. So that we call as gecko effect. So you can even search gecko effect, you will get proper idea about that. Right?
So now I have a small question. Now, does this application applies for spiders?
Yes. In the case of spider, it is yes, of course. Now I think if I have some images later, I will show you. So most of these creatures they are having the same sort of structural features. So that might be a reason for that as well. And also especially the gecko effect. So they have observed and they have come to the conclusions that they are using that particular the property in order to hang there. And also now the next example, the butterfly. So there are some butterflies, their color is not coming due to pigments, right? So that is due to the scattering of the light. So they are having again micro and nano structure in their wings. So therefore they are also whenever you can see when they are also the water repellent properties there because of their nano structure. And also they are having a structure called pagoda structure, that is also nano architectural structure. So whenever the light hit that structures due to this nano architecture, the scattering will be happen, right? So that scattering of that light will create some different colors. Basically, that blue color, I can't remember the name of the butterfly, because of this nano structure. And some other birds like peacock and all, they are also getting that hydrophobic property in their wings and their feathers due to these factors. So those are the good examples to prove that the nanotechnology is naturally occurring. Exactly. And also the people, the intelligent people, they observe those things and they come up with some other some applications using, as I mentioned, hydrophobic fabrics. And also I have seen one scientist, he tried to mimic that particular nano structure of that gecko toe, and he tried to do some climbing on the wall. Don't know whether it would succeed, but actually if you can come up with that sort of architecture, you can get that properties.
Thank you, sir. So to sum it up, are there any environmental and health concerns when considering the size of the particles involved? Like, how safe is the use of nanotechnology?
Yes, as in many ways, actually there are two sides of this as well. There are some benefits as well as some risk factors are there. So then in that case we have to check and balance. So we can't just say that these are toxic and these are environmental pollutants. If I say like that, I will use one example. Actually, I have recently saw in Sri Lanka, and annually there are 755 deaths are reported due to drowning. And but we say we can't go and swim or we can't travel ships, and so we don't ban it, right? So but we deal it. But if you take more and more water, again you are causing some illnesses called water intox. So but we don't ban water drinking, right? So therefore it's like you have to check the risk and benefits analysis, right? So therefore yes, nanotechnology, nanoparticles, basically those are very little particles. So even it can penetrate to the skin as well, and it can go to your inside and go to your body through injection or through inhalation. So if you inhale these particles, it can go and deposit in the lungs, and if you are having some particles which are not degrade for a long time, so it can cause some cancers as well. For example, silicosis is a well-known cancer. Asbestosis, so asbestos particles are the very recent thing, right? So therefore these are the things, right? So that will depend upon the material which you are using and the crystallinity or amorphous nature of this material, and also how much you expose to that, the concentration. So if you are exposing a very little amount, so that will not be a big issue. But if you are keep on exposing to the higher concentrations day to day, so So then it will be some effect on that. And these particles are here and there everywhere. When you synthesize these particles, these are, I told you, these are showing some very Brownian motion. Even in the air, this can be here and there. So these particles can go into the water bodies, and it can go into the soil and all. And also it can go into human bodies and others. So it can affect some causes actually. There are things are there. But as I mentioned, in everywhere you can see this type of things. So therefore you have to think now. For example, if you, let's say you are incorporating this carbon nanotubes into a bicycle frame, so it will give you a very hard, very strong frame, or let's say tennis racket. But it will not penetrate through your skin, right? So it is embedded into the system. So then you have to check the benefit you get out of that, so using that technology, rather than thinking about the risk side. But of course, when you synthesize nanomaterials, so you are exposing very much, right? So therefore you have to wear all the personal protective equipment, like you have to wear the gloves, and you have to wear masks, and you have to use some face shields and specific kits, and sometimes in names applications you have to use clean rooms, and there are some things are there. But I think for my experience, I have now exposed more than 10 years to these nanoparticles, but luckily I have not caught any kind of things related to that, right, toxicity. But you can't get rid of that as well. So you have to be, you have to be vigilant about that, and no need to be worry much about that as well, because it is there. You have to deal with it now. There are some antimicrobial socks are there. You have to wear it, right? So it will give you some additional benefits. So there are many things now. If you take, for example, even in the fridge, now there are fridge will release nano silver with time to time in order to keep the goods in safe mode, right? To prevent antimicrobial activities. And there are some nano packagings are there, nano sensors are there. So nano materials are everywhere. Now you have to deal with that, and you have to get the precautions in order to prevent them to be penetrated or inhalation or ingestion. But I don't think that you need to much worry about that as well. So there are two things. As I mentioned, you have to analyze it in the risk and benefit.
Alright. So moving on to our next question. Research in this field must be very costly. How is research related to this field funded? So how much are local authorities involved in the development of this field in Sri Lanka?
Okay, good question, Pudha. Actually, now when we talk about the funding and the authorities who are helping to develop this technology, actually we all know that we are all lucky that like NRC, National Research Council, and NSF, and all universities, they are having a mechanism to introduce some funding through grants actually. So even in academics, as academics, even we are giving some proposals, and they will evaluate it, and finally they fund us. So in that case, sometimes they might not concern whether it is nanotechnology related or whatever technology, but they will fund it, right? But I have seen, as I mentioned, there is a trending of all the scientists now. They are during their research or whatever their projects, they try to implement this particular technique because of their other brilliant properties. So they try to implement the nanotechnology into their proposals as well. And in that case, as you mentioned, actually the characterization techniques and all the equipments are somewhat expensive. But again, we are lucky that even in our state universities, few universities we have scanning microscopes and X-ray diffraction with diffractometers and the particle size analyzers. Even our university, our faculty, we are having many characterization equipments as well. And also, as a state of art, we have Sri Lanka Institute of Nanotechnology. You can get any sort of analysis done related to nanotechnology, starting from scanning electron microscope, transmission electron microscope, AFM, and PET analyzer, and particle size analysis. Everything will be under one roof. You can get into. So therefore, in that case, we are very lucky. And also, I have to mention here with my experience in my past work at Tech. So there are many industries, they are willing to do their research related to this technology. They all, almost every industry they involved with to do their research, and they have come up with some patents, and they have come up with some implementation of novel products and do some value addition to their existing product. So they are also enthusiastic to do actually the research related to nanotechnology. So therefore, entire community is well educated now about this, and they know what is the benefit and what are the risks, and all the things are now established, right? So therefore, people are always trying to do the research in this field, and as a result of that, the government funding agencies and not only Sri Lanka, globally, they all like TWAS and all their funding bodies, they will also like to fund for these technologies. So therefore, I would say not only for the nanotechnology but entirely to develop the Sri Lankan research culture in Sri Lankan government, and the other related bodies are giving a good help.
Okay, so guys, the next question going to be a very important one for us. How can a graduate with a degree in chemistry enter this field? What sort of higher education and postgraduate qualifications do they need to have?
Yes, actually, better if you have more qualifications before entering into any field. But basically, again, if I take myself for example, actually, when I pass out from my university as a graduate, I made chemistry. So, and when I entered to that particular field, actually, I didn't even know about the term nanotechnology. So that I didn't heard before. Because it was very new to us, even for the country at that time. So, but we did chemistry and physics. So that's what I wanted to highlight you. You should have a good knowledge on your chemistry and physics, because the nanotechnology basically based on physics, and chemistry will be support to that. Because whenever you come to the synthesis of nanomaterials, and these are all chemistry involved, right? But all these theories and phenomena are basically physics and chemistry blend. So therefore, if you have the basic knowledge, good knowledge about your chemistry and physics, so you are capable. That's my entry point to this question. That's why I took myself as an example, because now I am doing some lectures on this nanotechnology, and I have done many research and publications as well. So I started with my chemistry knowledge, and I did a bit of physics as well. But if you have many qualifications, because there are some opportunities even in Sri Lanka now, there is I am not going to mention the names, so it is not, I think, good, but there are some institutions, the universities rather, they are offering these MScs in nanotechnology and some diplomas, and in StreamTech you have some opportunities to join as interns, and you can do some research over there, and you can even join as a scientist, and you can start your career there. So therefore, not like us at that age. So even now in the universities, they implement these subjects in their under their specific specialization areas. Right? In our faculty, we have nanotechnology as subject. In Columbia University, they have nanobiotechnology, and your institute, you mentioned, you have nanotechnology, course, nanoscience and chemistry or something. So therefore, you are now very lucky. You can even hear these words and terms and things, right? You can learn those things. Not only that, actually, in school syllabus, there was some time back, one professor, she implemented curriculum to school syllabus as well. So therefore, from school time, now you have the opportunity to expose yourself to this technology. So therefore, I think I answered your question. So yeah, there are the basic qualifications are chemistry and physics, and you can learn beyond that, and there are many things to learn, but you have to develop yourself. So therefore, I can't name particular degree or postgraduate things that you can start and work hard and get knowledge about this with the help of those institutions and the facilities that you can utilize.
Thank you very much, sir, for that informative answer. So guys, I think we have come to the end of the discussion, and as for the final question from my side, Dr. Gayan, what do you have to say to all the undergraduates? who are willing to pursue a career in this field? And also, how prospective is this field when entering the job market compared to other career paths?
Yes, Nadia. Actually, the message I have to give at the end of this discussion is actually, as undergraduates, as I mentioned, who are having some opportunities to expose yourself into this technology, and you do it very well and you study well and you get some advices from experts, and also don't be afraid, and you always try to do some research, involve some research with the entities of who are funded regarding these things. And end of the day, if you are come up with some sort of research, so it will be a great great potential to our country, and as well as I from the beginning I mentioned for our economy as well. So therefore there are some inventions, I have some experience, so come into the actually come as a product. So there are plenty of opportunities are there. And also, as I mentioned, all the industries, they are now having R&D section in their industries, companies. So therefore, you have many opportunities to work there. They are also keening about this nanotechnological implementation of in their day-to-day products. So therefore, you will have a good opportunity as graduate when you graduate, right? And also, don't frame your future. Don't framework your future only into the industrial sector. So you can think as to become a lecturer or something. So you can be hope to become academia, right? So there, in that case, you have to develop your research skills and the set of number of publications. In that case, always better to engage with novel technologies rather than go for some kind of older technologies, because these are the demanding sections. So therefore, I always encourage my students to somehow find a path to convert your research into nanotechnological approach. So my message to students actually, even though you are focusing on industry, or even though you are focusing to become academia, so always this technology is there, and so you can use this technology in order to climb this ladder. So therefore, I encourage you to do involve these things. Don't be afraid. This is not anything, unachievable thing. So these are all achievable. These are chemistry. These are physics. There is nothing called thing called nanotech. There is a thing called nanotechnology, but it is chemistry and physics. So therefore, always I ask you to involve and explore your knowledge and get some advices from the experts and do your research, and someday you can achieve the milestones as I mentioned at the beginning. So my advice is that you can always use this technology for your the betterment of the country as well.
Thank you, sir. And thank you for sharing your thoughts about the nanoscience and nanotechnology related applications and all these ethical considerations and mainly all the importance of it. Today's resource person, Dr. Gayan Priyadarshana, lecturer in Faculty of Technology, University of Sri Jayawardenepura. Thank you for being here today and sharing your valuable time with us. So guys, I hope you all enjoyed our discussion and gained some new interesting facts about nanotechnology. See you guys in another episode. Thank you.